Welcome, ladies and gentlemen. This is Mr. Green, and this is another in my series to help you in geometry. What we're looking at today is a little bit more on congruence, okay? So, you should all be done with Unit 3, working on Unit 4 stuff now. I just don't want you to forget. You can make corrections to quizzes if you've got low grades, make corrections to unit exams and mid-unit exams. Get those corrections in because it will help your grade a lot. Don't forget, we are closing things every week, and it is affecting people's grades at this point. They're leaving zeros out there, and I hate to see that, but it's going to hurt your grade in the long run. So you need to make certain you're getting things made up within that 4-week time period. Moving forward here, what we're looking at is congruence, but we're going to step down a little bit, and we're going to look at an isosceles triangle. An isosceles triangle is a very special triangle in the geometric world. And I want to make certain that we get certain things identified about that triangle. First things first, there is a point on the triangle. There are 3 of them, really. But the one that is at the very top, the one that is opposite the 2 parallel sides, the one that is between the 2 sides that are equal is called the vertex. And the one that is down at the bottom, the one side that might not be congruent to the other 2, is called the base. We're talking about isosceles triangles here. And isosceles triangles are the ones that have 2 sides that are equal to each other. See how we got the 2 sides equal to each other here? So the vertex is the point that is in between those 2 equal sides. The base is the side that is not one of the 2 equal sides. That is quite simply the names of those sides. Now these 2 that are equal, the sides, we're going to call them legs. And the 2 angles that are opposite the legs are called the bases. The base is surrounded by base angles. The reason we use those specific names is because we get this isosceles triangle theorem, and it's proved in your book, so I'm not going to try to prove it for you and repeat what they're doing. That's a waste of your time and mine, okay? So what I'm going to do for you is I'm going to talk to you about the isosceles triangle theorem and how we apply it. It says if 2 angles in a triangle are congruent, then the opposite sides of those angles are congruent. What we're saying is if this angle, or this side and this side are equal, the pure definition of an isosceles triangle, then we know that this angle and this angle are congruent to each other. That is very helpful because we know in a triangle all the angles add up to 180. So if I just double either one of these and subtract it from 180, I'll find this angle. It helps us when we're looking at triangles, okay? Now the converse of the isosceles triangle theorem says the original statement says if 2 sides of a triangle are congruent, then the opposite angles are congruent. So what the converse would say is if the angles opposite a triangle in a triangle are congruent, then the sides are congruent. Okay, let's see if I can't get this to work for me here. Try typing this in. If 2 TWO, not TOW, 2 angles in a triangle are congruent, then the sides opposite those angles are congruent, and you have a isosceles triangle. That's the way I would state that converse. So what does that mean to you? That means if I'm looking at this one right here and I see that I've got an isosceles triangle, it's telling me it's an isosceles triangle. Where do I see it telling me that it's an isosceles triangle? Right here. See the little marks here? That means that these 2 sides are congruent to each other. If I know those 2 sides are congruent, I know this is 2x. What do I know about this angle? It's also 2x. Okay? So I'm going to just put 2x right there. That means if I add those all up, I get 9x. And I know the angles inside of a triangle add up to 180 degrees. That means that each one of those x's is equal to 20 degrees. So let's see here. L is 2 x's. That would make it a 40-degree angle. N is the same thing. That'd be 40. And M is 5 times that. That'd be 100 degrees. If you add those up, you'll get 180 degrees. Ta-da! That seemed quite simple, didn't it? That's what they did right there. Okay? So, look at this problem. Once again, we know it's an isosceles triangle. How do we know it's an isosceles triangle? Tells me right here. See these little tick marks? Those are isosceles triangle marks. We know this angle is 90, and we're trying to find this angle right here. I can take 180 minus 90. What's 180 minus 90? That's 90. And then I divide that in half. Why? Because this angle up here is x as well. And those two add up to 90 degrees. That means they must be 45 degrees apiece. Okay? And if this one's 45 degrees, this one over here must be 180 minus 45, or 135 degrees. So we found both those angles quite easily. No problem at all. Are the isosceles problem triangles any more difficult than this? Not really. They're all pretty much the same here. Okay, more complications. Just gotta love the way geometry works. We just gotta complicate everything. Let's look at what we've got here. Do you have enough information to solve for all 6 angles? And the answer is yes, we do. How come we have enough information? We see how this and this tell you that it's an isosceles triangle, but we also have this one. That means that all 3 of these sides are the same. That means 1, 2, and 3 are all the same. And if I take 180 and divide it by 3, you know what I get? 60. So 1, 2, and 3 are all 60 degrees. Woohoo! Easy enough to do. Okay? How about angle 6 here? Well, angle 6 is next to this one, and they form a straight line, so 180 minus 60, that must mean it's 120 degrees. Woohoo! That was easy enough to do. So now let's look at this other triangle over here, 4, 5, and 6. See that line there? That line there? That means those are congruent. That means angles 4 and 5 are equal to each other. If this one's 120, 180 minus 120, that's 60 degrees. And if I take 60 and divide it by 2, I get 30. That means I got a 30 here, and a 30 here, and 120 down here on this one. That was 2. I got all the angles done, and yes, I did have enough information. That's how you work these type of triangle problems. Okay? What we're doing, we're applying some triangle congruence relationships. We're investigating and working with polygons and their component parts and trying to find some information about them. These are the things that we've been trying to teach you. There are the things that the state of Texas says we need to teach you. So, don't forget, lots of courses. Need to make certain you're sending me the fact that you're in geometry and your section number. It really does help me, and I appreciate everyone who's been doing it. It really does help me find you quicker and answer your questions. I really don't like leaving you in the dark at any time. So, feel free, and I enjoyed it, and I'll talk to you next time.